What is going on, guys? Welcome to your 31st chemistry tutorial, and in this tutorial we're going to be going over the different types of bonds. And I know what you're saying, you're like, Bucky, you already told me covalent and ionic. Well, it gets even deeper than that, and I'm actually going to show you guys a cool way to predict the type of bond that can form between elements based on the electronegativity of that element. So let's go ahead and talk about some bonds that we are already familiar with. Hydrogen bonding with hydrogen. Now, whenever this happens, we already know that it forms a covalent bond. Basically, they share the electrons. Now, why does this happen exactly? Well, if we take a look at the electronegativity of each one, this hydrogen has 2.1, and this hydrogen also has an electronegativity of 2.1. So whenever electrons are in the middle deciding which hydrogen to circle around or orbit around, they're saying, okay, well, they have the same, so I guess we'll just orbit around both of them just like that. You know, it makes a pattern a little more neat than that, but that was the best I could do. So basically, depending on the electronegativity of each of these elements, if they are both the exact same, then we make something called a nonpolar covalent, we already know what covalent means, bond. Now, nonpolar pretty much means equal. I'll just go ahead and put it in really incredibly simple terms. So this means an equal covalent bond. In other words, the two elements have the same electronegativity, or they are really, really close. Now, this isn't always the case. You have, in some instances, something called a polar. Let me go ahead and write that a tidbit neater. Polar covalent bond. Now, this happens in the case of, say you would have, let me think of something, a hydrogen and a bromine. Now, bromine has electronegativity of 2.8, and hydrogen, of course, 2.1. So whenever we would draw this, we would, of course, get the hydrogen, and actually we probably don't even need to draw this, but it annoys me whenever I don't draw the valence electrons. So what we'd have is the hydrogen and the bromine would share this pair of electrons right here in the middle. However, it wouldn't share them equally because since bromine has a stronger electronegativity of 2.8 and hydrogen only has electronegativity of 2.1, the electrons would be more strongly attracted to the bromine. So pretty much they would tend to gravitate towards the bromine more, and if you would look at the electron path, may look something like this. That's a really bad drawing. I'm going to go ahead and get rid of that. But they're pretty much more likely to be gravitating around the bromine rather than the hydrogen because the bromine has a stronger electronegativity, a stronger pull. And we call this a polar covalent bond. Now, polar pretty much just means unequal. They're more likely to gravitate towards one side as opposed to the other side. And we already know what covalent means when they share, and we already know what bond is from like James Bond 007. That's where I learned most of my terminology from Nintendo 64. So the last type of bond we have is, of course, ionic, and there's only one type of ionic bond, thank God. Now, an ionic bond can form between two elements, and we know that they don't share anything at all. So say we have NaCl, which is sodium chloride, and sodium, let me go ahead and find the color, has an electronegativity of 0.9, which means it's actually really weak, and chlorine has an electronegativity of 3.0. So whenever one element is so much stronger than the other element, then it could actually cause an electron from the sodium to pop over and hop right on top of that chlorine. So it can actually steal an electron if that force is strong enough. Now, if you're saying, okay, how do I know if the force is going to be strong enough or not? Oh, hold on. Got like phlegm in my throat from eating like 30 chicken wings about an hour ago. But anyways, so the difference in electronegativity can determine which type of bonds that will form. If you have a difference of 0 to 0.2, then you have a nonpolar covalent bond. If you have electronegativity, probably should have left me some space here, of 0.3 to 1.4, then that's when you have a polar covalent bond. And if you have a difference between two elements that is 1.5 and above, then the difference is so strong that it forms the ionic bond. In other words, it steals one of those electrons and pretty much it steals it. So this is again uh, well, you already know. I'm not going to explain ionic bonds again. Go watch my tutorial on ionic bonds if you want to know how these elements are bonded together. But anyways, that's the difference, and those are the numerical values. And no, I just didn't make those up. That's what the science book is telling me. So anyways, thank you guys for watching. Don't forget to subscribe, and I will see you guys in the next tutorial.